In this video, I'd like to talk about the variations of the Pythagorean identity. And really, this idea extends to all identities in trig. Anytime you see an identity presented to you, it's written a particular way, but we're allowed to shuffle things around. We can use identities to rewrite other identities into different formats. So it can be overwhelming, the list of identities you see in trig. Really, there's just some key ones to know and know how to work out the other forms. So I'll just share that with you with Pythagorean identity. This is definitely an identity you will probably use the most in trig, this along with its variations. So this is definitely the format you want to make sure you remember. Sine squared of any angle plus cosine squared of that angle will always be 1. Okay. So the thing to remember is that because we have an equation here, the two sides are balanced, I can shuffle things from one side to the other as long as I maintain the balance. So if I wanted to bring the sine squared to the other side, we could rewrite it this way, subtract the sine squared from both sides. So this is another version or variation of the Pythagorean identity. If you ever encounter a cosine squared, you could always replace it with a 1 minus sine squared if it's helpful, or vice versa. If you've got 1 minus sine squared, you could say, oh, that's a cosine squared. Another thing is I could have left the sine squared alone and moved the cosine to the other side. And so we could get the sine squared all by itself, subtracting the cosine squared to the other side. Again, it's another variety of the Pythagorean identity. So they all just come from taking this one identity and just simply moving one trig function to the other side of the equation. But you'll be surprised how many times we encounter things like this or things like this. And so it's very helpful to be able to simplify and make things more condensed. Okay, well, there's other flavors of the Pythagorean identity. So this is the only one that I bother to memorize. The rest we could find out using one more identity from trig that's very helpful. Tangent of any angle is always equal to sine of that angle over cosine of that angle. We can make big use of that guy. And we've also got to remember some reciprocal identities, that secant, or rather cosecant of any angle is 1 over sine, or rather sine of an angle is 1 over cosecant, right? We can go either way with those reciprocal identities. And we also remember that secant of an angle is 1 over cosine of that angle, or vice versa. 1 over cosine is 1 over secant of that angle. So we've got to keep in mind some other identities, but using these, we can take this one Pythagorean identity in yellow and see it a few different ways. So let's take the Pythagorean identity, the one we have memorized. And let's say I want to get a format that involves secant. Let's just say I'm looking for secant. Okay, well, if I look at secant, I see that I get a secant when I have a 1 over cosine. Okay. Well, that means if I were to get a cosine under here, I'd be looking at secant. And I could do that. I could divide both sides by cosine, as long as I divide everything by cosine. But if you look at the left, it's not going to clean up too nicely. Nothing's going to simplify here, and here you're going to be left with a cosine. So it is an identity, just maybe not that helpful. But look what happens if we divide by cosine squared on all sides. Okay. Well, 1 over cosine squared, that would be secant squared. Cosine squared over cosine squared is 1. Anything over itself is 1. And then here I've got sine squared over cosine squared. Well, sine over cosine is a tangent. So that means this thing must be a tangent squared. And there we have another variation of Pythagorean identity. And just like we did up here in blue, you could take this equation and shuffle things around. You can get the tangent and secants on the same side. You could write it a couple different ways, and whatever way suits your needs. So let's look at one more format we can derive. Right, there's Pythagorean identity. This time, take a look at what happens if we were to divide everything through by sine squared. As long as we divide everything through on both sides of the equation, we're good. Well, the sine squared over sine squared is 1. Cosine squared over sine squared. Notice that's the reciprocal here. Instead of a sine over cosine, we have cosine over sine. That gives us cotangent, and in this case squared, since both the cosine and sine are squared. And 1 over sine squared is a cosecant squared. So yet another version of Pythagorean identity, which again can be written a few different ways just by shuffling things around. I find it hard to just flat out memorize formulas. So the only one I have committed to memory is good old standard Pythagorean identity and my reciprocal identities here and how tangent is related to sine and cosine. And from those, you can get all other forms of Pythagorean identity. And again, this idea really extends beyond Pythagorean identity, and it's true about all identities in trig. You can use other identities to rewrite anything you're looking at into a different format. Sometimes it's helpful, sometimes it's just muddying up the water, but we have that freedom to do that to our identities in trig. All right, hope this helps. Keep up the good work.